Today we're going to learn how to identify functions. You should be on page 36 in your notes packet. To identify functions, you first need to know what a relation is. This is because every function is just a special type of relation, so we need to understand what relations mean. In math, a relation is a set of pairs of input and output values. Input values are always your x values, and output values are always your y values. There are multiple ways to represent a relation. We represent them as ordered pairs, input-output tables, points on a coordinate plane, and mapping diagrams. We also represent them as equations. You're used to seeing those equations written as y equals maybe a number times x and then plus or minus something. So that would be an example of an equation that is a relation. We also can represent them in words, and so we'll talk about how to see all of these in just a moment. Some examples of relations are this. This is a mapping diagram. In this mapping diagram, your first oval would be your x values, and your second oval would be your y values. In this, we see that we have an input of 0, and when we have an input of 0, we have an output of -2. When we have an input of 1, we have an output of 1. When we have an input of -2, we have an output of 4, and we also have an output of 3. You can change these and write these as ordered pairs also. So this could be 0, -2, 1, 1, -2, 4, and also -2, 3. So you can see that you can take any of these and write them in any other way. Another example is this set of ordered pairs. So this is a set of x and y values where you have an input and output because each x value is an input and each y value is an output. You notice that they are written inside brackets to represent that this whole set of ordered pairs is one relation together. We also have input and output tables, which are usually just called XY tables, and a lot of times they don't have the words input and output with them, but you could take these with if X is -1 and Y is 5, again, you could write that as an ordered pair. You can also write this as an equation. I could write Y equals 9X plus 2. In this equation, I could put in a value for X. So for example, I could put in 2 for X. If I plugged in 2 for X, that would be 9 times 2 plus 2. Well, that would give me a value of 20 for Y. So when X is 2, Y is 20. Some non-examples of relations are numbers like 4. Those are just constant numbers, but they do not have an X value or a Y value. Just one variable, either X or Y, would not be a relation because you actually need an input and an output. So you need an X value and a Y value at the same time. The same is true for 7x. That is just an expression, but we need an equation where you have a y value and an x value so that you can get an input for each or an output for each input. Now we represent relations in a lot of different ways. So I've talked to you a little bit about these. When we write ordered pairs, we always write a relation as a set of ordered pairs that are in brackets with commas in between each ordered pair. So for example, you see that we have each ordered pair, and remember that ordered pairs are inside parentheses with a comma separating them. But then to separate each ordered pair, you also see another comma, and you notice that all of these ordered pairs are within brackets to show that this is one relation and that all of these are related to each other. An input-output table, like I showed you, the input is always going to be your X value and the output is always the Y value. So sometimes you have a vertical table, and if you have a vertical table, your X value is always your first value and Y is always second. If you have a horizontal table, X is always the top value and y is always the bottom. So here are two examples for you. I'm sorry, I wrote over that one. On a coordinate plane, the x-coordinate tells us to move left or right, and the y-coordinate tells us to move up or down. So we have ordered pairs, and so if we have a coordinate plane, we put those ordered pairs on our coordinate plane. Mapping diagrams are when you have boxes or ovals, and you write the input in the first box or oval, and you have to make sure this part's important. You do not repeat any values. Then in the right box or oval, you write the output values. Again, do not repeat anything. And you draw an arrow from each input to its output. So, for example, in this, 0 has an output of -2 and an output of 1. Well, this would have been, technically, 0 would have been written twice, but in the input, you only put it one time. 1 has an output of 2. 2 has an output of 1. And 3 has an output of 4. So you can take all of these and write them as ordered pairs, but when you put them in the mapping diagram, you should only write each value one time, even if it appears more than once. So I just showed you how to find the ordered pairs from that mapping diagram. And if we were writing these in a list to show that this was a relation, again, we would put them in brackets with parentheses separating each ordered pair. Now, how do we use all of this to find functions? A function is really just a special type of relation. So a function is still a relationship between an x value and a y value, or an input and an output. But it is a special type where every input will have exactly one output. This is very important. All functions are relations. All functions are just special types of relations where the input has just one output. But not all relations are functions, because functions are just special subtypes of relations. All right, so characteristics of functions. For one thing, if you have a graph of a function, you can use the vertical line test. So if you can draw a vertical line through the graph and it only passes through it one time, then it is a function. And so we call that the vertical line test of testing on a coordinate plane. In this one, you can see that if I took a vertical line and I drew a vertical line anywhere on here, each vertical line will only pass through this one time. So even though I could draw multiple vertical lines, the vertical line will only pass through each of these just one time. Because of that, that tells me that every input on this has exactly one output. So I would know that that is a function. So we would say, yes, this is a function. For this one, if I drew a vertical line, you'll notice that I have a point that passes through here and here. So that means that whatever this input was, it would have an output or a y value here and another y value here. Because of that, I would say that this is not a function. It is still a relation, it's just a relationship that is not, or a relation that is not a function. For this one, I can see that if I drew a vertical line, I would pass through this more than once. So this is also not a function. For this one, if I drew a vertical line anywhere on here, it's only going to run through that graph one time. So because of this, I can say that this is a function. So some examples of functions. Obviously, if you have a coordinate plane, if you have a graph, something like this, it looks like it might not be, but if you put a vertical line anywhere through here, even right here, it only passes through in one particular place on the graph. So because of this, this would be a function. Y equals 9x plus 2 is also a function. This is because I could plug in any value for x. Whatever value it is, it's going to give me one value for y. I couldn't plug in any value for x that would give me two different values of y. So because of this, I know that this is a function. In this input and output table, I see that every input has one output, so -1 only has the output of +5. 0 only has an output of 3. 1 only has an output of 1. 2 only has an output of -1. And 3 only has an output of -3. Because of this, I know that this is a function. In this set of ordered pairs, at first glance, it looks like maybe this would not be a function. However, when I look, every time I have an input of 1, I'm only going to have an output of 2. An input of 2 will also have an output of 2, but if I put an input of 2, the only output that I can get is 2. An input of 3 will also give me an output of 2, and an input of 4 will also give me an output of 2. Now, although all of these have the same output, that doesn't matter. What matters is that if I have an input of 1, I'm only going to be able to get 2, which is only one value. If this were not a function, it would have something like 0, 1, 2, 3, 0, 4, 1, 6. So in this case, you had an input of 0, which gave you an output of 1, and an input of 0, which gave you an output of 4. Because that input of 0 had two different outputs, that would not be a function. In this mapping diagram, you can see that every value over here in your input only has one arrow coming off of it, which means that every value in your mapping diagram only has one output. So because each input has just one arrow coming from it, you know that this is going to be a function. Some non-examples would be this, which we've talked about already, because if we did the vertical line test, it would go through this graph more than one time. This mapping diagram is not a function. So you notice that when we have an input of -8, there are two outputs. There's an output of -6 and an output of +1. Because of that, this would not be considered a function. In this set of ordered pairs, -6, -4, -2, +1, 0, 6, and -2, 5, we have an input of -2 that has an output of 1 and also an output of 5. Because that input of -2 has two different outputs, that would not be a function. In this table, you can see that you have an input of 4, which gives you an output of 7, and you have an input of 4 that also gives you an output of 14. So because that input of 4 gives you more than one different outputs, this is also not a function. Now you are going to practice on page 38 by finding out which of these are or are not functions.